right, so let me give you one more quirky one. Suppose you had x is less than -3 and x is greater than +3. All right, so does anything satisfy this inequality? Well, this describes numbers to the left of -3 and also to the right of +3. Now, do you know of any numbers that are both less than -3 and also greater than +3? There are no such numbers. And so this set has no solution. The set is empty. And so I would write no solution. Now, textbooks tend to overuse the empty set signal, the symbol. And that's the empty set symbol. I don't like it here because I think it's a little misused. It's not good communication. You know, I'd rather you talk to me in English. Tell me there's no solution if there is no solution. And so I kind of prefer you not use that because I think it gets overused and misused in lower level mathematics. All right, so I'm going to steer you away from these kinds of situations. The problems I'm going to ask you to do typically are pretty normal. And now I haven't begun to tell you about the other logical conjunction word, or. So let's talk about or. And the word or is a little more complicated. The way we use or in mathematics is typically as the inclusive or. So what I mean by this, an or statement is true if at least one part of it is true. And so if I said the sky is blue and the grass is green, true statement. I'm sorry, let me start over. If I said the sky is blue and the grass is green, that's a true statement. Both parts are true. What if I said the sky is blue or the grass is red? Okay, well, in a mathematical sense, in a logical sense, that would be regarded as a true statement. All right, I know it's kind of a weird statement. It's not how we normally think of things in plain English, but in math we have to be consistent about our definitions, how we agree on things. And it turns out to be a bit more practical in the long term to think of or as inclusive, which means that if one part is true, then the whole statement is true. So if I said, you know, the sky is green or the grass is red or the sea is purple or Southern State is in Ohio, that's a true statement. Because the first three were false, however, the last statement was true. All you need is one part to be true for an or statement to be true. All right, so let me show you how this translates into these inequalities. And here's a typical type of solution you may end up with. Okay, suppose that x is less than 0 or x is greater than 10. I was thinking today I had this type of solution come up in my Calculus 3 class I was teaching. I believe this was the solution we came up with to a problem we worked. All right, so let's see what this means. X is less than 0. Well, let's put 0 here and 10 there. Okay. So x is less than 0 means I shade to the left of 0. X is greater than 10 means I shade to the right of 0. And I used open circles as before because they're less thans. The word or means that we're going to include both. We're going to unite these groups. And so if you ever study sets, this is a set union. Not a set intersection, it's a set union. And so if a number belongs to the set, it either belongs to this part or that part. For example, how about -1? -1 is less than 0, that's true. -1 is not greater than 10, that's false. But it's okay, because again, the or statement, as we're using it in mathematics, if one part is true, then the whole statement is regarded as true. So -1 belongs to the set because it's in one of these two halves. So OR statements, as we'll see them, typically look like this: split intervals. And this makes sense. If you take college algebra, you'll be solving absolute value inequality problems. And absolute value is how we represent distance on a number line. And so this might describe objects which are more than 5 units away from 5. So 5 is the exact number here. And if I want to know what are all the numbers that are more than 5 units away from 5, then that would describe this set of numbers. And in absolute value, that would look like absolute value of x minus 5 is greater than 5. All right, so you can get these kinds of inequalities or intervals from absolute value equations. And absolute value equations come about due to ways of measuring distance. Well, we don't study absolute value in this course in that way, but you'll be solving some problems like this. In interval notation, then, sounds like a helicopter's outside, we would say that x belongs to the interval, parentheses, negative infinity, comma 0, close parentheses, or parentheses, 10 comma infinity, close parentheses. So I'm going to, I have two parts, and I connect them with the word or. So forget the word or, you're going to miss some points. Forget x belongs to, you're going to miss points. If you write xe instead of element symbol, you're going to miss points. So do it right, learn it right. Now this would be perfectly fine to me. Another way to write this is to use the union symbol, which is a U, kind of a straight capital U. The union symbol means the same as or in this context, so feel free to use it if you like that. And the and symbol, incidentally, is the upside down U, and that means intersection as well. But anyway, I'll probably write the word or when I do problems instead of using this symbol, but it's up to you. I don't care. All right, so there that is, and well, we'll see some more as we move along. And again, your course textbook has some quirky problems in it that may not look in this form when you get done, but the problems I give you will tend to look like this. Or they'll either be between, it'll be a sandwich inequality, in other words a single interval, or it'll be one of these split intervals. Because this is what you most would normally see. If you take some higher math, you'll start running into this, and it'll make a lot of sense when you do see that.